Hi everyone, I'm Alex. I'll present our work on promoting relevant results in time rank mail search. So we want to increase the quality of search results in mail search. And one way to do that is to just sort the results by relevance. We know that increases the metrics, we know that increases the relevance, but we don't want to do that because that users generally don't like when you change stuff too much around, and that would be a drastic change in their experience. Also, the results would be less browsable because when the results are in reverse chronological order, the users understand the order. In relevance, it's a bit harder. And finally, it doesn't fit all queries. For example, when a user searches for contact, maybe the best way to show the results is in reverse chronological order. To illustrate that, the benefits of relevance, we collected 100,000 queries with their clicks after the query, and we define time success at 10 as the percentage of queries for which the clicked result was in the top 10 messages when the messages were sorted by time, and failure when the click was on some other message. Another dimension we could look at these same queries is where was the click when the messages were sorted by relevance. So this produces 4 options. The upper left quadrant is when both time and relevance produced a result list such that the click was high in the list. And the bottom right, 12% was when both of them basically failed. But what's interesting here is the 7.5% we see where the relevance was successful, meaning that when the results were sorted by relevance, the click was in the first 10 messages. But when you sort them by time, the click was somewhere lower. So obviously for these queries, you would want to sort the result by relevance. But as we said earlier, that's impossible, or we don't want to do that. But what we could do is maybe take some results, some relevant results, and put them on top of the time-sorted list. In that way, the user experience would be roughly the same, and we could still use a relevance algorithm and show the most relevant results on top. And in case the user doesn't like them, he can still browse by date and get his usual experience that he's used to. So our model is we define some sort of a window of messages the user sees after a search, let's say K, and we limit the number of heroes we can show so that we don't fill the whole window with heroes. The majority still has to be time-sorted messages. So we have some space for heroes, and our algorithm should choose those heroes out of the messages, and then they'll be shown on top. And the question is, well, whether you can have duplicates between the time-sorted list in the window and the heroes, and whether you can use up all that space or just part of it. So the simplest algorithm, and maybe the most intuitive one, is take the most relevant results, choose those as heroes, the most relevant results out of all the list. And you can do that, but they might be too similar or even identical to the top time-sorted list results. So you would have duplicates, or there could be an exact match. To solve that and eliminate duplicates, we propose another algorithm, which we call heroes fixed, is where we say that we know we're going to choose some amount of heroes, H heroes, so we know exactly which messages will stay in the window, which means these 4 messages in this example. So we will choose our most relevant results out of all the rest of the messages. Because these ones are already in the window, we don't want duplicates. We're choosing the most relevant messages out of the rest of the list. However, this could still be a problem because our chosen messages might be less relevant than those time-sorted ones. And last algorithm we propose to somehow alleviate that is to do it iteratively, not choose the whole bunch at once, but go one by one, find the most relevant message that's not in the window, and then compare it to the last message in the window. If the message we want to add is more relevant than the one that's going to be kicked out of the window, we choose it as a hero. And we stop when either that's not the case or when we fill out the whole allotted space for heroes. We're going to see some examples real quickly. But before that, in all of these algorithms, we always keep the window size k. So that means that whenever we choose a hero, the time-sorted list becomes smaller. Our heroes are always less than our limit. And every time we choose heroes, the average relevance in the window increases. So the results are more relevant, the quality grows. In our example, this is a time-sorted list of messages, and the numbers are the relevance scores of each message. The rectangle is the window that the user sees. So for time-sorted results, the user sees the 5 most recent results. Now, if we want to apply the first algorithm, we just choose the 3 most relevant results out of all the list. It's these 3. Choose them as heroes, so now they're on top. And that leaves us with these 2 time-sorted results still in the window. And there we have it. These 2 messages are duplicate. If we take the second algorithm, so here we know that those 2 on the top will be in the window. We choose the most relevant ones out of the rest of the messages. Now, we don't have duplicates in the window, but there are messages that are less relevant and still on top. That could still be bad user experience. And finally, for our iterative algorithm, which we look at the most relevant message outside the window, compare it to the last message in the window. Is it more relevant? Yes. We choose it as a hero. Now it's on top. We do it again. The most relevant message outside the window is this one. Is it more relevant than the last message in the window? No. We stop. So for the iterative algorithm, we choose one hero, and this is it. We evaluated them. First, we did an offline evaluation, where we chose 2 metrics that are industry standard. So interestingly, they behave differently for different metrics. For example, for the success at 10 metric, which measures whether the click was in the first 10 or not, we see that the algorithm, the first one, the duplicates, is worse than even sort by time, while the fixed and the iterative are good in that metric. They just improve as the number of heroes grows. And that makes sense because if you just look at the messages in the window, then when you have duplicates, you just lose space, and the results go down. But in the MRR metric, which actually takes rank into account, choosing the most relevant messages increases the metric, while having no duplicates basically, again, makes it worse than sorting by time. So that's the offline evaluation for those 100,000 queries. We also did an editorial evaluations where editors were asked to issue queries according to different patterns of queries, and then try it out on all 3 algorithms and just the time-sorted list. And then for each list, they would have to fill out what was the rank of their message that they wanted to find. And again, we measure our metrics. So we see here that this correlates with our offline evaluation, where the success metric was the hero fixed and the iterative were better for the success metric, while for the MRR, the duplicates one was better. But interestingly, when we asked them which one they prefer or what was their experience, so they chose the heroes duplicate ones. And also they prefer to see heroes rather than just see time-sorted list. So basically that tells us that as far as metrics go, users prefer to see MRR metric other than something that's like success at 6 metric. So rank matters. And finally, we did an online evaluation. And also, here we just implemented the best algorithm that performed well so far. And we can see, again, in a real system in Yao an increase of 12% in MRR and some increase in success. So to conclude, sorry, to conclude, we did several evaluations, both offline, online, and a bucket test. All of them aligned. The hero duplicate algorithm provided the best MRR, and users preferred to see heroes rather than just time-sorted list, and they wanted that algorithm that showed duplicates, which brings us to the conclusion that it's okay to show duplicates as long as the most relevant results are on top. Thank you.